In this question, we're given some tables that show relationships between x and y, and we have to find out which of them is a linear relationship using first differences. So, if we subtract successive x values and successive y values, and the differences are consistent, then we know it's a linear relationship. Okay, let's give it a go. Let's start with A. So I look at the difference between -3 and -2, and that is +1. If I do the following, we see that's also +1, and the next two, it's +1. So the x values are increasing by 1 each time. Now let's look at the y values. So the difference from 9 to 6 is -3. The difference from 6 to 4 is -2. And the difference from 4 to 3 is -1. So we can see that the differences here are not consistent for the corresponding differences in the x values. So therefore, we know that A is a nonlinear relationship. So let's repeat the process for the other tables. So we'll go down to option B. So the difference in x values again looks like they're going up by 1 each time. And then let's look at the differences in y. So to get from -5 to -3, we add 2. To get from -3 to 0, we add 3. And to get from 0 to 3, we add 3. So again, although the x values are going up consistently by 1, the y values are not. They're going up by 2 and then 3 and 3. So therefore we know that this too is non-linear. Okay, let's go to option C. As we move along here, the difference in the x values is +1. We're increasing by 1 each time. And in the y values from 0 to -2 is subtracting 2. From -2 to -4 is subtracting 2. And from -4 to -6 is subtracting 2. So the difference in the y values is consistent for the corresponding increase in the x values. Therefore, we know that this must be a linear relation. So it looks like we found the answer, but let's just verify. Again, we'll go down to D here and see that as we go along the x values here, we're increasing by 1 each time. And then if we look at the y values, the difference here is +5, the difference here is +10, and the difference here is +15. So the difference in the y is not consistent for the corresponding increase by 1 in the x. So we know that this is nonlinear. So C is the right answer. But let's do one other thing here. What happens if we had, let's take this linear relationship table here, and let's say we didn't have this third pair here, this x and y pair. And the question would be, is it still linear? Well, let's take a look at the difference here between 3 and 5. That means we're going up by 2. And for between -2 and 6, that means we're going down by 4. And then you might think, well, the difference here is not consistent, and the difference here is not consistent. But what we're really looking for is the ratio between these two x and y values to be consistent. So let's look at the ratio between y and x. So for the first one, we can see the difference in y is -2 and the difference in x is +1. So what we can do here is the difference is -2 divided by 1. So the ratio is actually -2. Now let's look at the ratio for the second difference, -4 and 2. So that becomes here, change in y is -4 and the change in x is +2, which also gives us -2. So when the ratios of the differences between y and x is the same, then it is a linear relation. And you might recognize this value here to be the slope of the line. And there you go.